And hello there. Welcome to our Data Summit Connect, Track C, Database DevOps. I'm Mary D. Ojala, Conference Program Director. And today we are going to have two presentations in this session, giving two perspectives on deploying via AWS. So we will be starting off with Grant Fritchey, who is with Redgate Software, and following him will be Chris Paap with Nutanix. So Grant, why don't you get started all about what you have to say to us?
Okay, thanks a lot. Let me just get the screen up on. There we go. Should be working now.
Looks good. Go ahead.
Cool. There we go. All right, let's talk about AWS and deployments. Before we go, my name is Grant Fritchey. I work for Redgate Software, and this is my contact information. If you have questions after today, please don't hesitate to reach out and get in touch with me. I'm a Microsoft MVP. I'm also an AWS community builder, and I'm really into this whole concept of database automation. So anything you want to talk about, I'd love to help out. So you've got the information. Let's get going. Here's the agenda. I want to talk a little bit about DevOps, a little bit about what AWS is, and then I want to walk you through a simple CI process using AWS. We've got about 19 minutes here, and that's plenty of time to get through all of this. So let's just level set real quick. When we're talking about DevOps, what we're really talking about is not any particular tool or any particular process. Instead, what we're talking about is a really simple concept, improving collaboration between people. And we do this through process and tools and automation in support of that process. So people are at the top. Let's just right up front say that. People are at the top, process is second, and then the tooling and all that stuff comes later. Now, the issue that you're going to run into, the tooling's hard. So we should talk about that, because once you're getting to that point, that's what we're here to address and figure out. So talking about AWS, what I'm going to talk about particularly are three tools out of these four. I'm going to spend time today talking about CodeCommit. We're going to talk about code pipeline, and we're going to talk about code build. I'm not going to spend a lot of time on code deploy. We're going to glance over it just a little bit. I'm going to focus on the other three because they are where most of the activity is. We'll talk about code deploy some just to get you going with it, but you'll get the idea as we go through. So this is the stuff we're going to cover. So let's just start off with CodeCommit. Oh, and by the way, if you guys have questions, there is a window you can type into, and I can get the questions and try to answer them. And I think there's a Q&A period after we're done with both our sessions, mine and Chris's. So just so you know, just make sure you don't hesitate to ask those questions. So first up, CodeCommit. CodeCommit is simply a repository, a repo. It is based on Git. It is completely Git focused. You can run Git locally and then push up to this, but it is a source control management system, and it's one that just happens to run on AWS. I love it. It's a great tool. It works well, but here's the key. You have to get your code into it. Databases, traditionally, we don't put any of the database in, or traditionally, you only put in, say, stored procedures and views, stuff like that. But the key that you're going to have to get to at some point, if you intend to really and truly automate all of your deployments from your database, is you are going to have to move all of your code into source control. And the fact is that all databases are code. If you're working in Postgres, MySQL, SQL Server, Oracle, any of these, and even if you're running AWS Redshift, at the root, those things are code. Code goes into source control. Why into source control? Well, two big reasons. One, it gives you a known point, a known moment in time. These are the changes that we made for version 1.1, for branch 5. However you're determining your markers for your source control, We know what changes have been done. We know what things have been done because we're managing our code through source control. So when you need to determine, gosh, something's broken, how do we figure out what happened? Well, you've got an audit trail. Oh my gosh, who deployed this? Well, you've got a way of looking it up. And I've gotten in trouble for this. What idiot made this change? And then you go and look, and of course it was you. Myself. I'm the idiot. It gives you all of that through source control, and you get all the capabilities of Git. So branching, the idea of local versions that you can then control, deciding when to push, when to pull, all that fun stuff, all completely managed through your AWS mechanisms. Now, could you instead use GitHub or some other storage mechanism for your source control? Absolutely, you could. There's nothing that says you have to use this, but we've got it there. If you're working within AWS as an automation mechanism, then you've got another place to store your source code as well. So might as well take advantage of it. So that's source control. Next up is code pipeline. Code pipeline is more or less a management system. It has a set of triggers. For example, the thing I'm going to show today, the trigger is commits to my source control in AWS. So when I push from my local code up to the cloud, what I'm going to get is a triggering event that will then cause my pipeline to run. But you can set up other triggers. You can have a pipeline call another pipeline. You can have a build call a pipeline. You can schedule pipelines to run. So it's supportive of your process and your infrastructure, but it is the control decision methodology. It is the if this, then that mechanism for getting through things. It directs the actions, and setting this up is step one for creating your continuous integration process. Now, whether or not you're doing multiple deployments beyond continuous integration, deployments into QA, deployments into pre-production or staging, then deployments into your production environment, the processes are all going to be the same. I always try to start everyone off on a continuous integration process, just because CI can be divorced from data, and therefore it makes it a little easier to code initially, and then you're just going to do the same thing to QA. You're just going to do the same thing to your staging environment. So once you understand pipelines and how they work, then using them in other locations for other processes just gets easy. It's just a question of building out and doing more and more and more stuff once you've established the basics. So that's why I always start off with continuous integration, because it's the basics, it gets you going, and then you can expand from there. All right, the next thing that we would be talking about is code build. Code build, really simple to understand. YAML, build spec.yaml. It's a YAML file. By the way, you don't have to name it build spec.yaml. You can name it something else if you want to. But the idea is it's a series of command line arguments. But it's not simply that. It's also a series of commands that you can run pre-deployment, deployment, post-deployment, build. You can do a whole bunch of series of steps and additional if this, then that type approaches within this. Finally, it can generate artifacts for you. Now, what do I mean by artifacts? Well, if we're talking databases, especially if we're talking relational databases, I'm talking SQL. You're talking a PostgreSQL, MySQL, T-SQL, whichever one you're using, doesn't matter, but you can generate that SQL command, have that available for your later deployments or as a record of what happened for your deployment. I'm a huge fan of generating these artifacts because it provides an audit trail and lets you see what's going on. And then finally, code deploy. Now, code deploy generally is used to consume artifacts, and code deploy is how you hop environments. So a build process can run and generate the artifact, but to get that artifact between environments, you're going to want to put deploy to work. It does a lot more for you in that instance. So while I'm able to run a build here that I'm going to run for you to do a continuous integration process without using deploy at all, I would not recommend doing that necessarily for your QA build, staging build, and certainly for your production build. One thing I haven't talked about here in this fairly short presentation and demo is security, and I do want to mention that really quickly. AWS is inherently secure by default, so I mean, I wouldn't sweat the fundamentals of security, but the way you set up your deployment processes, the agents that you use, and the other additional things you do need to sweat your security there, because you can, just to pick on someone that happened last year, SolarWinds, a great organization, not throwing rocks here, but they did get hacked through their code deployment tool. It was not, by the way, AWS. It was another tool. But they did get hacked through that tool because they did not have the proper security on that tool. So that's something you do want to think about here, is because this technically kind of has the keys to the kingdom, depending on how you set it up. So you want to be very cautious. So that's that. So the other thing I'm going to use today is a open source tool called Flyway. It is the little magic bit in the middle, because you've got all of AWS doing all of your work, for managing the pipeline, for managing the code through code, and then managing the build process through code build. All of that stuff is being done, but how do you get the database build to happen? I'm using Flyway. It works on Windows, it works on Linux, it works with 20 some odd different database systems, all of which, or many of which are available on AWS, but also Azure, Google Cloud Platform, or locally on-premises stuff. So and it's all open source. So it is the magic to get you going across there. The one thing I will say about it, it is migrations approach, which means it is an accumulation of changes, a series of changes over time laid out. And we'll see when we look at the code here in just a second exactly what that means. But this is the tool that, that we're going to use to do that final step. So let's go. Let me get to CodeCommit. There we go. This is a really simple, I'm going to walk you through a very simple CI process over the next 8 minutes. Now, this is my CodeCommit on AWS right now. This is my build spec.yaml file. Let's go ahead and take a look at that first. And what I've got here, just make it a little bit bigger so you guys can see it more clearly. What I've got here is I highlight out a bunch of commands, but we have the phases: the install, the pre-build, the build, and the post-build. And so you can control your build processes through any one of those steps. And then I've got a series of Flyway commands that I've run, all of them through Docker. So what I'm doing is I'm using Docker to fire up a container with Flyway inside of it, and then I do my deployments from there. The deployments are actually going to AWS. This is a Postgres database that I'm running, but it'd be the same process with MySQL or Oracle or whatever. But I'm able to run Docker run, and then migrate is the command to make stuff move. But we've also got, while I'm experimenting, I've got stuff for repair, for validate, for clean, all different mechanisms within Flyway for getting stuff done. But let's talk about what Flyway can do for us. The way it works, let me get to the SQL. Here we go. It's all down to this naming standard. So you'll notice I've got V1, V2, V4, V5.1, 5.2, 5.3, V6. These are my scripts, and you do have to order them in the correct order they need to run. Flyway will figure out which ones have to be run and which ones don't, but you need to put them into the correct order. Now, they can be very complex scripts, or if we take a look at this one, it can be very, very simple. All I'm doing is an alter table command. Simple stuff, nothing complex. So you get the idea. You can also make it much more complex. Also, you've got repeatable scripts. So these are like views, stored procedures. They can run every time, so that ensure that any code changes are captured and updated. And then you also, and this is an enterprise only or teams only thing that you would actually have to pay for, you can supply undo scripts. We're not going to talk about that much because I want to stick to the open source stuff that you guys can do right now. So that's the basic setup. I've got source code in my CodeCommit window, and I can do work from there. So now let's talk about build. Now, what I've got here is I've got a couple of different build processes. I've got a QA build and I've got a CI build. And that's because my pipeline actually does several different things. Let's take a look at the pipeline real quick. So the pipeline, the way it's laid out is it's taking stuff from source control, ta-da. It's running a build process. If that build process succeeds, it runs a second QA build process. Assuming that works, it has an approval step in the process. So it will stop everything and it will wait and ensure that, I approve whether or not stuff is there. So what I can do is I can click review. I'm not going to do it right now, but I can click review. It will show me the T-SQL I have available. And you'll see right now, it's just sitting here waiting. It's waiting for me to say, yes, in fact, go make this deployment happen. And then the finally thing that we'll do is it will deploy to production. And you'll notice my last deployment failed that I was running, but I intentionally failed it. I put some bad code in just to watch it die. It's silly me. I like doing stuff like that. At least when I'm working in test, I would never want to do that in a production environment. That would be bad. But there's the idea. Now the code build, we've already seen the code build.yaml file, but oops, nope, that was not the one I meant to click on. Sorry. There we go. We've already seen the YAML file. Let's go ahead and just take a look at the output from it. The idea is really simple. It's the agent itself is going to get in there. It's going to run. It's going to configure everything that it has to run. It's going to run the stages that we defined within that build.stop.yaml file. And then here it goes. It's running the command docker.flyway migrate. Flyway itself is going to go and run its commands. It's going to get all of the code. It's going to validate the checksums against the database. Once those checksums are validated, it's deployed the database and any updates that have happened. In this case, it only had to move one thing. It validated 29 migrations, but it moved one. And so that's a complete deployment. It's very straightforward, very simple, not that hard to set up once you've connected all the dots. And that's the issue. Working through the stuff to go from CodeCommit and managing everything through code through a pipeline process, through a pipeline process that allows you to see what's going on and control the flow and determine how it is you want to run. And then having each of the commands running the code build so you guys can run through those code builds all the way through. It's actually a lot of work. It's easy once you got all the dots connected. So that's just the one thing I would say is plan on just one step at a time, right? Eat the elephant, one bite at a time. It's really not that bad. Let me switch back to my slides here. Right, demo time. We just did the demo. Okay, cool. The one thing I will say, the last 2 minutes that we have, start with source control. If you're not already in the habit of managing your data code, your database definitions, all the store procedures, all the tables, triggers, everything. If you're not in the habit of managing that through source control today, start that habit. That's the key. You've got to have that be a fundamental process of what you do. Next, learn how to do the things that you do through the command line. If you're not already familiar with scripting it all and putting it all together through command line processes, get into that habit now. Learning YAML is nothing, right? It's simple, but learning what goes into YAML to get it right, that's some work, and you're going to have to spend some time taking care of that. Next, build a CI process. Build a dumb CI process. Build a really simple one like what I have here. All it does is fire up connect to a database, fire the commands to do the build, and that's it. That's all it does. It's very simplistic, but it's a framework on which you can hang the very complicated stuff that you're going to do later when you're dealing with data and you're dealing with testing and all of the various things you can do. You can expand from there. If you've got the ability to run an automated CI build, you can then get an automated production build. It's just a bunch more work to get to that point. So start with these simple steps: source control, command line, and a CI process. That's it. My name's Grant Fritchey. I work for Redgate Software, and thank you for your time.
Thank you so much, Grant. Yeah, I love the idea of starting really simple and then building into stuff that's a bit more complicated. So now let me turn the podium, virtual podium, over to Chris Paap, who is Senior Solutions Marketing Manager with Nutanix. So Chris, go ahead.
Thank you. Thank you for the introduction and wonderful presentation by Grant. Let me get my presentation up. All right. Here we go. So my name is Chris Paap. I work for Nutanix as a database solutions marketing manager. I have about 12 to 13 years experience on the practitioner side before coming over to the software product management and product marketing side. And since that time, I've been working with databases, particularly with Nutanix. One thing I want to kind of dig into as we jump into here and as we jump into the challenges, I want to bring something up that Grant said that I keyed on, was that when we're talking about DevOps culture and people being at the top of that list of DevOps culture, that's where I'm going to take this presentation to. It's going to be from the aspect of giving IT practitioners and DevOps teams more time to do their job and do it more efficiently, particularly how from a DBA standpoint or systems engineer, how they can assist those teams to get those jobs done. And when I'm talking to nearly on a daily basis, different teams and customers, the challenges for like DevOps databases in relation to putting databases out on AWS, the challenges they're running into are kind of fall into the 4 pillars of risk, cost, complexity, and agility. I think the agility one is pretty clear a lot of times. If you just have the traditional infrastructure and you don't have the tooling and the automation set up, that capability to answer at the speed of business when the DevOps teams or any team for that matter needs a database to deploy a full like LAMP stack environment. It could take a long time. Databases have a lot of moving parts and there's a lot of teams involved with it, as we'll see later on in the presentation. But that ability to react and give them what they need when they need it and exactly what they need is a problem that they run into, or teams run into quite a bit. And that's brought up from complexity. There's just so many moving parts. There's different database silos. There tends to be different database teams, and whether it's SQL, Oracle. There's if you're running in AWS, you have the teams that are in charge from a cloud perspective. It could be cloud architects and DBAs. Now that what we're seeing are sharing that title. They're adding that to their repertoire of being a cloud architect because they're rolling stuff out into RDS, or they're getting EC2 instances up, or bare metal out there. And so, they have these bunch of little different silos out there. So you have different teams answering, and it takes a while. And you just have more environment, more infrastructure, even if it's in the public cloud, to manage and try to keep under one umbrella, when in fact what you have are separate environments. And the truth of the matter is we're rolling things out and databases out. Companies are in a even if their strategy is to be primary public cloud, they do have a hybrid cloud setup, because there's things that are just living in the on-premise environment as well as in the hyperscaler environment. So how do you manage both those? And the risk is, if you don't manage those, it can be a lot of money. It could be downtime. If you have a project that's really churning along, you delay that project, or it's not rolled out correctly. Example of this, when you add the complexity of the different environments out there, the risk that's associated with it is just everything's its own snowflake. Every application, every database is its own snowflake. So there's no standardization or automation rolled out in there. So or the standardization, or I should say the automation, or you built from the ground up grassroots efforts of scripts. They're not repeatable between the different environments, the different silos, so it causes a lot of issues. You add those things up and you mix that in with being having an on-premises and in public cloud, and what we're seeing in those scenarios is especially with Nutanix, like how people are getting their foot in the door with us, is they're looking to move, particularly in terms of an initiator or a workload, their DevOps practices or their development environment. They're looking to put their foot in the door specifically from databases to do that first. And so they have like a mixture and spread all over the place. So how do they consolidate that? Whether it's moving it all to public cloud or moving it on-prem, how do you manage both those and keep it, have the same policies, have the same configurations of your databases, and make sure that you're following security and compliances across the board, and then being able to manage that life cycle of the database is pretty hard. So, what is the answer to that? How do you do that and take care of that? So where in an environment where you don't have any unified database management, you can gain that. And so before I kind of walk through these things, I kind of want to set the stage of what Nutanix does. We provide a platform that we're known for a hyper-converged infrastructure, upper right-hand quadrant. We can provide a central control plane or a platform for databases, for Oracle, SQL Server, MySQL, Postgres, MariaDB, SAP, and HANA on a distributed platform on HCI. So that's kind of the requirement for it for us to run and manage those databases is be on our web scale architecture that we can then extend up to AWS. But that gives you some abilities and extend capabilities on data protection, cost governance, and application automation as well. And then we build that database as a service for like the pillars are like provisioning, patching, upgrading, cloning, refreshing, and be able to kind of get your arms around that and extend that out and simplify those database operations that tend not to be automated, and they actually put some standardizations in those processes and then run those across anywhere your databases exist, whether it's private or public cloud, for what we coin the hybrid cloud database. So we're able to take that on the common consumption models and manage that. So if we look at that and we kind of apply that to like the existing process that's out there today, when you go to deploy a database or however that ticket comes in, let's say from ServiceNow, that you need a database for your dev team, and that if you are on the DevOps part of that DevOps team that's requesting that database, it's a lengthy process, and it's not just because nobody's working on it. Once the request comes in to where it comes into the database team, you need to have the database team, the infrastructure team, storage team, you have the compliance and networking team checking that out. It's lots of steps. That's if it happens one after the other. It's not a wash, rinse, repeat a lot of the times if there's not that automation built in. It's a lot of friction involved, a lot of wasted time, as each database gets deployed, because it's not going to just be one database. What you end up having is differences in configurations that roll out, especially, and that's important because if you want that, that dev environment to match your production or test environment to kind of match all the way through as you roll in an application out. You want those same configurations. You want the same database instance and type and patch level, right? Or if you are patching them after you deploy the database, you want them all to match up. So they're all covered and there's no security vulnerabilities. So this is time consuming. It's not at the speed of business, and it takes a long time and can delay the time to market if you're deploying an application or that is contingent on that database getting out. It's a very slow, lengthy process. And so when we're kind of managing it, or what we talk about simplifying that, is what we're doing is taking automation. I mean, that's a key thing. That's the hard part. It's easy to say to automate, but how do you take all those different steps where you have a different storage team, networking team, compliance, and security team, and bake those all in? Basically, what we're doing is we're taking a gold image of the databases, and then we're creating that and setting that up, and then creating a service catalog, if you will. So once the ticket comes in, you can take two options. One is that DBA or systems administrator can, as soon as the ticket comes in, they can then deploy it, and it is a cookie cutter wash, rinse, repeat. So it's a best practice. So you're going to get the best performance for that database. It's going to be best practices for that database engine and for Nutanix. Or if we are deploying in AWS, best practices for AWS. And it's done in minutes, right? So it's the best practices, best performance, and it's no longer taking hours or days. It's in minutes that can be deployed. So it is at the speed of business. So all those steps are eliminated. It also does a benefit of when it comes time to troubleshoot, or that time to resolution, because you don't have those variables involved from a lot of manual database operations work, or deploying a database out there, where you have the different configurations of different database instances that are deployed. You have that standardization, and that standardization layer helps out when you're troubleshooting an issue. So you know what that standard is, and you don't have these variables out there that you have to take into account. So the time to resolution is much faster, and the uptime for the database and the associated application is much faster as well. And so the benefit of that to the DBA or to the development team is that now they're getting the time back, right? So they're not sitting there twiddling their thumbs. They're able to jump on that project and roll it out and do what they need to do. And so because they're not troubleshooting, because they don't have performance issues, or they're sitting there on a process, they can now, that those nights and weekends, those times that where they were, working in the off hours, you start getting that time back. Or you get the time to focus on other projects that kind of move the business forward, is what we find as well. Instead of putting on that firefighting helmet and troubleshooting the environment right when they walk in. And that also has, on the flip side, that DBA or systems engineering team isn't having to do that, or that database architect is not having to put in tickets to find out what's going on to get an environment up. So it doesn't muck up the system. So it's a win-win all the way around. One of the things that when we're talking about automation and talking about empowering users is when we do this, whether you're running something like ServiceNow or some other or some type of ticketing or service catalog, we can integrate with that. So if you're providing services and you have delegated those operations out, where somebody needs an application, they click on their service catalog and deploys it, or if they're using a current automation tool that rolls out the application, and when it comes to the databases, because we're fully API, fully open API, it can plug into our database as a service and deploy that database out. So when it's deploying that application to be installed in that dev environment, it can then call out to Era and then to provision or clone that database to the next environment. So you have, again, the best practices, and it's easy, and you can set up and automate that. The other thing is in that process too, one thing I pointed out is that when it's coming through in the provisioning that is required, you're kind of eliminating the manual task of it forwarding on to somebody else by just delegating that out and giving those parameters of whether it's t-shirt sizing, or you're setting up rule sets or policies on based who can do what where. You can then just put the power in their control, so that development team is now able to deploy at will. And you have a full lifecycle management, how long it's going to live out there, how long, if it's part of a project, you can set those parameters around that. And so whether it's something else that you've already set up from an automation standpoint, or you're just coming in from a ticketing standpoint and deploying a database, you can do that, and you can provision, clone, configure it, and then as part of that process, if it's time to update the data, which is part of the cloning process, or patching, it's standardized across the board. So it saves time, it's efficient, and it empowers the team to continue to move forward and to help the company in terms of being resilient and hitting those deadlines. So, I'm talking about deploying in databases, but one of the things, and this is just a quick kind of slide I want to throw up there when we're doing this, is a lot of scenarios we see that, again, like I said earlier, is that, companies tend to start out by putting databases on us in their dev environment. And so we are talking to a lot of customers from from a DevOps perspective, what is their strategy? What are they doing? And so a lot of the times, when we're setting stuff up, they're asking, how do you integrate into, our AWS environment, or how can we leverage you for that? And so when we're using our database as a service, one way we can do that is we can actually manage Both those, whether it's multiple clusters or in the case of, say, if you're running like SQL and always on group availability group, you're able to keep those policies the same. So you're looking at, even though they're in distinctly different areas of being in your data center or in an AWS zone, what you can do is extend those policies of what you have from a compliance perspective, or data retention policies, whatever those are, and you can now extend those out across the board. So you're not having a separate set of rules to manage. It's also great having like that central control plane to see what, the level of where your databases are at, patch levels, versioning, configurations, and being able to, and then address those and manage those, refreshing, being able to take advantage of what we call like 0-byte clones. So those are essentially snapshots. Instead of taking, full, copy of a data set and then trying to move that around, you're taking a snapshot, point in time snapshot, and then just changes to that database or what's being registered. So it's saving a lot of storage. It's not taking a performance impact. So those are the benefits, right? So and that saves time. So if you have terabyte sized databases that you're trying to replicate that data to different environments, specifically across public cloud and on premises, being able to do that in a manner where it's a lot less data, and it's also a lot more time efficient than just a copy and paste procedure, or backup and restore procedure. It's very efficient and fast, and it's one of those things that not only saves time, but it's a benefit where maybe you're doing more data set updates or taking more backups to your environment than you wouldn't do before, because you don't have that performance impact. So it's pretty much what I wanted to touch with today. If you have any questions, feel free to, I'm going to be available to ask any questions, after this presentation. But if it's something that you want to do and go and kick the tires on and see what we do to kind of the different pillars of what we do from an automation standpoint for databases, we do have a test drive. So nutanix.com/test-era is how you get to it, or just search Nutanix, Google Nutanix test drive, and you can find the databases section. And it's kind of a good way to, without implementing anything, you can actually kick the tires, and it's a guided tour. So appreciate the time. My name is Chris Paap, and thank you.
Thank you, Chris. So I want to know why you're not wearing that outfit with the helmet. And we do have a couple of questions here. We have a few minutes for them. This is somebody who says that his company does not own Nutanix, but can he still run Era database as a service for the DevOps environment?
No. So like I said before, like a lot of people are, the way we get into environments is for, development workloads, dev test workloads. But the requirement is to have the Nutanix infrastructure in place or running Nutanix on bare metal AWS. So that is a requirement before running our database as a service.
Okay. And also for Chris, what are the requirements or products necessary to run Nutanix databases in AWS?
So it's a really good question. So there is an option when you're deploying it into AWS. The product is called Nutanix clusters. And that essentially is to run the Nutanix operating system on bare metal AWS. And then the additional option is to have our database as a service product, which is called Era, Nutanix Era. So those are the two things you need.
And Grant, not with the Nutanix databases, but just in general, what requirements are you looking at in deploying something with AWS? Is there an overall, level to look at?
No, not really. I mean, it's pretty much any of the products. The only key is that you've got to have that little magic bit, the flyway thing, or build yourself, or look to third-party products. Redgate actually has several tools that we could sell you. But if you want to look at open source, there's Flyway and there's some others. But it's that little bit of magic to get what's in source control onto databases.
Mm-hmm. I loved when you were talking about connecting the dots, because I saw a cartoon the other day that said, well, the guy was frowning at his screen and he was saying, I'm trying to connect the dots, but I don't have any dots. And, I think, I mean, it's funny, but at the same time, some of us are in that situation where, yeah, we'd love to do this, but we're missing some key components here.
Start with source control. That's the key.
Start with source control.
Start
Okay.
with source control. It's a weird thing for DBA types to dive into source control, but that's where to go.
Would you agree, Chris?
Yeah, it's actually some great advice. In fact, he's right. It is weird for those kind of DBA personas to kind of be diving in there, but I'm seeing it more common in today's world.
Great. Okay, well, we are at our time here. So thank you to both Grant and Chris. And if you have some extra time, we could all go over to the networking area, click on track C, and we can continue the conversation over there. So thanks again, you guys.
Thanks.
Thank you.